Hi everyone. This lesson is on taking special triangles and converting to using the unit circle. So our learning goal is to learn to use the unit circle to find exact trig values. So last week we learned how to use special triangles, and this week we're going to learn how to use the unit circle and why the unit circle might be a good way or an easier, quicker way of doing it. So recall the special triangles. So hopefully if you did last week's lesson, you remember that the sides, we have the radius is 1, the x value is 1 over root 2, and the y value is also 1 over root 2 for the 45-degree special triangle. For the 30-degree special triangle, if the radius is 1, then the x value is root 3 over 2, and the y value is 1/2. And for the 60-degree special triangle, if the radius is 1, the x value is 1/2 and the y value is root 3 over 2. Okay, so what the unit circle is it's a memory aid diagram that stores information about commonly referenced angles in trig. It uses symmetry and the special triangles to store information. So here is an example of just taking the 60-degree triangle from here, from up here, and fitting it into the unit circle, what that would look like. So first of all, why do they call it the unit circle? It's because the radius is 1. So this distance 1 from here to here would be 1. The radius is always 1. Okay, and that's why they call it the unit circle, 1 unit. Okay. And then, so if we have the 60-degree angle in, we know that this point here that would be on the, you can think of it as the outside of the unit circle, would have the coordinates over 1/2 in the x direction, so this would be the x, and up root 3 over 2 in the y direction. So this point here, if it's on the outer edge of the unit circle, and this is a 60-degree angle, would be from 0, 0 over 1/2 up root 3 over 2. So that point would have the coordinates 1/2 root 3 over 2. Okay, so now we're actually going to make our own unit circle. So hopefully you've printed it off. If not, you might want to stop the video and print it off because this is a hard one to just take notes on. So here's the unit circle that we have. So since we did the 60-degree, I just showed you the 60-degree. I think we're going to start with the actually no, we're going to start with labeling the x and y axis here. So here's our x-axis and our y-axis. So rather than starting with the 60-degree, let's start with, so what I'm going back to here is angles and quadrants. And what we're going to label then is like 0 degrees, 90 degrees, 180 degrees, 270, and back to 360. Okay, so we're going to start off labeling those angles. So let's come back to our unit circle here. That's where that idea comes from. So this spoke here, if you want to think about it as a spoke on the unit circle, or the wheel, some people call it, represents 0 degrees. And this one up here at the top represents 90 degrees and 180 degrees, and then 270 degrees at the bottom. And then back to the start again is also 360 degrees. Okay, so back to angles and quadrants and what the different angles are. This is the x-axis and the y-axis, but also we have some points then. If this is a unit circle, then this point here that I'm filling in would have the coordinates, so over 1 in the positive x direction, up 0. And then at the top then, if I put a point here, and remember this is the unit circle, so right here where they cross, that 0, 0. So this point up here at the top, if it's a radius of 1, would be 0 left or right, positive 1. And then on the left here, this point here from 0, 0 would be -1 for the x, and then not up or down, -1, 0. And then at the bottom, this point would be 0, -1, so not left or right, but down 1. And then again, 360s back to 1, 0. Okay, now let's do the 60 degrees. So if you have 3 colors, that would be helpful. So I'm going to put in my first spoke here, and this one represents the 60-degree triangle. So and that means from 0 to this pink spoke would be 60 degrees, but I'm just going to label this 60 degrees here. Okay? And then we just, on the last page, showed that to get to that, and you don't have to draw on this dotted line, but I'm just reminding you of what actually this means here. So if this angle is 60 degrees from here to here, if that angle is 60 degrees, and the pink length of the pink spoke is 1, then this ordered pair here would be in the x direction over +1/2, and then up √3/2, and that's based on our 60-degree special triangle right here. Okay, so x is 1/2 √3/2. And that's 60 degrees. Well, there's 3 other angles that are related to the 60 degree. This one, so I'm coloring it in pink, which is 120 degrees. So and all we're doing is turning that special triangle and flipping it over. Its coordinates, because we're in the second quadrant, the x is going to be negative. So in the second quadrant, x is negative, and y is positive when we're in the second quadrant. Okay, so if we think of this as being 0, 0, this distance would be -1/2, and that, but still positive √3/2, and that's at 120 degrees. And then if we're at 60 degrees away from 180, that's going to be 180 plus 60, that's 240 degrees. And if we're in the third quadrant, we should remember that x and y are both negative. Okay, so if we're in the third quadrant, the x and the y are both negative. So this point would be -1/2 for the x, -√3/2. And then the fourth angle related to the 60-degree triangle would be 60 degrees down from the positive x-axis here. And that angle is 300 degrees, 360 minus 60. And in the fourth quadrant, x is positive while y is negative. Sorry, x is positive while y is negative. So this would have the ordered pair 1/2, and then the y value would be -√3/2. So you can see I fit the 60-degree triangle into the 4 different quadrants. And they all had 1/2 or -1/2 as the x value, and √3/2 or -√3/2 as the y value, depending on the quadrant we were in. All right, so now let's do the 45-degree triangle. So I'm going to use yellow for that one. So there's my first 45 degree. So we're going to label it 45 degrees. And then this point on the outside, so if we look at our special triangle for 45 degrees, which is right here, the x and y are both the same. They're both 1/√2. So if I was trying to get to that point from 0, 0, I would go over 1/√2 and up 1/√2. So that would be my ordered pair. And then I've got 3 other angles that are related to 45 degrees. So I've got 45 less than 180, which is 135 degrees. And that point on the unit circle would have the coordinates. So again, and the x is going to be negative in the second quadrant, so negative 1 over root 2, but the y value is still positive. And then we've got our 45-degree related angle in the third quadrant. So that's going to be 180 plus 45, which is 225 degrees. And the coordinates, both x and y are negative here, so negative 1 over root 2, negative 1 over root 2 would be the ordered pair there. And then in the fourth quadrant would be 360 minus 45, which is 315 degrees. And the coordinates of the point on the outer edge of the circle would be positive for x, so positive 1 over root 2, negative 1 over root 2. And then lastly, I'm going to use green for my 30-degree angle here. So this angle's 30 degrees. Then this point, according to my 30-degree special triangle, the x is root 3 over 2 and the y is a half. And then we have three other angles related to the 30 degree. 30 degrees less than 180 is 150 degrees. And in the second quadrant, the x is negative, so it's going to be negative root 3 over 2. But y is still positive, 1/2. And then we have 30 degrees more than 180, which is 210 degrees. And both are negative here, so it's negative root 3 over 2 for x and negative 1/2 for the y value. And then we have 30 degrees less than 360, which is 330 degrees. And then this ordered pair would be positive root 3 over 2 for the x, and then negative 1/2 for the y. So normally when we're in school, I would have a quiz and a couple of days where I just give you a blank unit circle and you have to put on for it every angle, every one of these angles between 0 and 360, and every ordered pair on the unit circle. Because memorizing this will be very helpful if you're going to take math in grade 12 and then beyond in university. Especially in some universities, you can't use a calculator in first year math, and so then knowing these values without having to look them up on or just find them on a calculator is useful. Okay, so we've kind of organized all this information into this unit circle here, and so then some cues on how to memorize it if you wanted to take the initiative and memorize it for next year. So first of all, I'll show you a quick way of memorizing the angles. So if we just ignore the yellow, so the 45s, we can get all the angles by counting by 30. So 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. So if you just leave out the 45s, you can get all those angles just by going up by 30s, okay? And then if you want to get the 45s, I leave out the 30 and 60s and just use the T and the yellows. So you can count by 45s this time. So 0 plus 45 is 45, and 45 is 90, and 45 is 135, and 45 is 180, and 45 is 225, and 45 is 270, and 45 is 315, and 45 is back to 360. So if you did that, you would have all the angles done. Now, and then hopefully just by knowing that this is a circle with a radius of 1, you would be able to get the coordinates for I call this like the T part. So 1, 0, 0, 1 up at the top, -1, 0 at the left, and 0, -1 at the bottom. Then if you just focus on the first quadrant, so, and again, remembering that root 3 over 2 is bigger than a half. So for the 30-degree angle, you can see that you go over more than you go up. So root 3 over 2, a half. But for the 60 degrees, it's reversed. You only go over half and up root 3 over 2. So you have to memorize that these are reverse of each other and that root 3 over 2 is the longer one. And then also then you've got to memorize that the 45, they're both the same and they're 1 over root 2. But once you have this first quadrant, then they stay the same. So all the pink ones have the same numbers in the same order. So they're all a half root 3 over 2, but the signs are different. So negative a half, positive root 3 over 2 in the second quadrant. In the third quadrant, negative a half, negative root 3 over 2. And then in the fourth quadrant, positive a half, negative root 3 over 2. So once you've got the first quadrant, you just need to know the sign rules for X and Y in the second, third, and fourth quadrant. And you can get all of the ordered pairs and all of the angles. So why is that important? So let's go through that a little bit now so we can still write this on our unit circle here. So we know that the sine of an angle from our angles and quadrants is the y value over the r value. But in the unit circle, r value is always 1. So on the unit circle, the sine of an angle is just its y value. So if I was going around, for instance, and I wanted to know the sine of 120 degrees, it's just the y value at 120 degrees. It's root 3 over 2. So if I have this unit circle memorized and I can see that in my head, I do have it memorized. I know that the sine is the y value at 120, which is root 3 over 2. So similarly, the cosine of angle theta is x over r, but on the unit circle, the r value is always 1. So the cos of an angle is just its x value on the unit circle. And the tan is the y value divided by the x value. So say I wanted the tan of 60, the y value divided by the x value. So I could think to myself, root 3 over 2 divided by a half, and the denominators are the same, so it's root 3. So it's a simple calculation that I can kind of do just by looking at the unit circle in my brain if I've got it memorized, or on paper while I am memorizing it. Okay? And okay, so then the other thing is, say I want the sec. Well, it's r over y, but on the unit circle that's 1 over y. 1 over a value is the same, oh sorry. Go back. Cosecant is r over y, which is 1 over y, which is really just the y value flipped. So let's look at an example of that so you can see that it's really just the y value flipped. So say I wanted the cosecant of 210 degrees. So I'm saying it's 1 over the y value. So if I look at 210 degrees, the y value is negative a half. So 1 over the y value. And I know that when I'm dividing by a fraction, I'm multiplying by the reciprocal. So that's going to end up giving me negative 2 over 1, which is just negative 2. But remember I said it's the y value flipped upside down? So if I look at cosecant of 210, I'm going to go to 210, look at my y value, which is negative 1/2. If I flip it upside down, I get negative 2 over 1, which is negative 2, and I don't have to show any of that work. I can just know it. So cosecant is the y value flipped upside down, and secant would be the x value flipped upside down. And then cotan, though, is the x over the y. okay, but also easy to do because they're going to have the same denominator. All right, so we're going to keep your unit circle handy and we're going to try these. So use the definitions of primary and secondary trig ratios to determine trig values from the unit circle. So I don't know why I left you all that space there. You don't need it. We're on here then. Use the unit circle to find the exact value of each of the following. So the cosine of 210. So we said that on the unit circle, cosine is the x value. So if I look at 210 degrees, the x value is negative root 3 over 2. So the cos of 210 is equal to negative root 3 over 2. The sine of 330. So we said that on the unit circle, the sine of an angle is its y value. So I'm going to look at 330, look at the y value, it's negative 1/2. So the sine of 330 is negative 1/2. The cos of 495. Okay, so this one's a little trickier because 495 is not on my circle, but I can find out where it would be on my circle by finding the principal angle, which we learned about that last week. So cos of 495 is going to be the same as the cos of whatever 495 minus 360 is. 135. So again, why does that make sense? So if we're looking at our unit circle here, all the way around once is 360, and then 135 more gets me to 135. So this is where I would be on the unit circle. So the cos of 495 is the same as the cos of 135. So it's important to know that since those angles, 495 and 135, ended up being in the same spot on the circle, their cosines are exactly the same. And on the unit circle, the cosine is the x value. So let's look at the x value at 135, and it's negative 1 over root 2. So again, we can use our calculator to check this. So let's try the cosine of 495 degrees. Make sure your calculator's in degrees, and you get negative 0.707. And then try negative 1 divided by the square root of 2. Same decimal, negative 0.707106. Okay? All right, the secant of 120. So we said that secant and cos are related. So if I knew the cos of 120, I could flip it upside down and that would be the secant. So let's find 120. The cosine is negative 1/2. If I flip that upside down, I should get negative 2. How can I check on my calculator and see if that's right? I would do 1 over the cos of 120. 1 divided by the cos of 120, negative 2. Cosecant of negative 300. First of all, I want to get it onto the circle. So I want to find, if it's a negative, I'm going to add 360 until I get to the principal angle, or the angle that's between 0 and 360. So cosecant of 60 degrees. Guess I don't need the bracket. And again, let's look at our circle and see if that makes sense. So negative 300 would be going this way 300 degrees, which would get me to here, which is 60 degrees. But remember, cosecant is related to sine, so it's going to be the sine flipped upside down. And we said that on the unit circle, sine is y, or cosecant is the y value flipped. So the cosecant of 60 is going to be, if you look up here, the y value, which is root 3 over 2, flipped upside down, so 2 over root 3. And that might be one we want to check for sure with our calculator. So we get, to do that, would be 1 divided by the sine, and I'm going to use brackets, of negative 300. Gives me the decimal positive 1.1547. And then let's try 2 divided by the square root of 3, same decimal, 1.1547. And remember, we're not giving approximate answers here, we're giving exact values. So that's why it's important to be able to use either special triangles or memorize the unit circle to get these, because they're not asking for decimal approximations, they're asking for the exact value. All right, so cosine of 450, first let's get it onto the circle. So 450 is greater than 360, so I'm going to subtract 360 to figure out what the principal angle is. So that gives me 90. So 90 is one that's not really a special triangle, but it is on the unit circle. 90 degrees is right at the top here. Cosine of 90 is the x value at 90. So the cosine of 90 is actually 0. That's one we haven't really talked about. So let's try that on our calculator. So let's try the cos of 450. Should give us 0. And that's what we got using our unit circle as well. All right, tan of 240. So that's going to be, so 240 right here, the y value divided by the x value. So you can write it out in full if you want to. The y value is negative root 3 over 2 divided by the x value, which is negative 1/2. Remember, if the denominators when you're dividing fractions are the same, they divide out. So you end up just having to divide the numerators. Negative root 3 over negative 1. Negative divided by negative is a positive. So the answer is positive root 3. And if you can just go straight to positive root 3 by looking at the circle, that's fine. It's like having the circle memorized, being able to manipulate those values in your head. And then we can try it out on our calculator. So the tan of 240, 1.732, and then root 3, also 1.732. Cotan of 150. So cotan is the x over the y. So find 150, the x over the y. So that's going to be negative root 3 over 2 over positive 1/2, which turns out to be negative root 3 over 1, or just negative root 3. Again, if we were trying that out, you would do 1 over the tan, because there's no cotan button, of 150. And then comparing that with negative square root of 3, same decimal. Tan of 405, so first we want to get it onto the circle, and since 405 is greater than 360, to find the principal angle, we're going to subtract 360. So 405 minus 360 is 45 degrees, which makes sense. So 405 would be all the way around once and then 45 more. So we'd end up in this exact same spot. And we want the tan, so that's the y divided by the x. And notice for 45 degrees, x and y are exactly the same. So if you divide 1 over root 2 by itself, you're going to get 1. And then you should be able to check that on your calculator. Tangent of 405 is in fact 1. Okay, so getting more complicated, sine squared of 300. So if you remember when we did the cast rule and angles in quadrants, I told you that sine squared is another way of writing sine of an angle all squared. So I'm just reminding you of that. If you remember it, that's fine. Some people might recognize, well, sine squared of theta plus cos squared of theta is always 1. So this should turn out to be 1 because the angles are both 300 degrees. It's the same angle, but let's prove it to ourselves. So the sine of 300, the y value at 300 is negative root 3 over 2. But we're squaring it. The cos of 300 is 1/2. The x value. We're squaring it as well. So when you square negative root 3, you're going to get positive root 9, which is 3. And when you square 2, you're going to get 4. Plus, a half squared, so 1 squared is 1, 2 squared is 4. So 3/4 plus 1/4 is 4/4, which is 1. So the identity holds true then. Sine squared of 300 plus cos squared of 300 is 1. The next one, this says 2, it's really 3 things multiplying together. So the number 2 multiplied by the sine of 210 degrees multiplied by the cos of 210 degrees. We did something similar in angles and quadrants. So the number 2, then I want to multiply that by what the sine of 210 is. So on the unit circle, sine is the y value. So the sine of 210 is -1/2. The cos of 210 is the x value at 210, so -√3/2. And then I'll just make 2 so it has a denominator, because when you multiply fractions, that's the easy operation. You multiply all the tops together. So 2 times -1 times -√3 would be +2√3. And then you multiply the bottoms together. 1 times 2 times 2 is 4. And then 2/4 reduces to 1/2, so it's just √3/2. And again, you could check that on your calculator. 2 times the sine of 210 times the cosine of 210. You get this decimal 0.866025. And then try √3 divided by 2, same decimal. So 2 cosecant 60 times secant 60, again, that's 3 things multiplying together. The number 2, the cosecant of 60, and the secant of 60. So the number 2, cosecant's the sine flipped upside down. So the y value at 60 flipped upside down. So it's going to be 2/√3. The secant of 60, secant's related to cos, so it's going to be the x value flipped upside down. So instead of 1/2, it's going to be 2/1, or just 2. But then we want to make them fractions, so we multiply the tops together. 2 times 2 times 2 is 8. 1 times √3 times 1 is √3. That should be our answer, 8/√3. If you wanted to try it on your calculator, you would have to do 1 divided by the sine of 60, then press equals. Multiply that by 1 divided by the cosine of 60 equals, and then times 2. So decimal I got was 4.618, and then 8 divided by the square root of 3, 4.618 as well. The right answer. Next one, tan square root of 510 degrees plus 1. So first I want to do the tan of, I want to find where it is on the unit circle, so I'm going to subtract 360. But that's all squared plus 1. So 510 minus 360 is 150 squared plus 1. Tan of 150, so that's the y divided by the x. So if we find 150, the y value is 1/2, divided by -√3/2. So I'm going to write it out. So the at 150, the y value is 1/2 divided by the x value, which is -√3/2, big huge bracket here, all squared, plus 1. And we know that we can divide the denominators out, so I'm just going to be left with -1/√3 squared plus 1. Square -1 and you get +1. If you square root 3, you get 3. And if you want to add 1, you can add 3/3, which is 1 written another way. So we have a common denominator, and we end up getting 4/3. And we can try that out on our calculator. So we would try tan of 510, press equals, and then squared, square that, and then add 1. 1.333333 repeat, which is 4/3. Next one, so sec of 210. So sec's related to cos, so it's going to be the x value flipped upside down at 210. So that's negative 2 over root 3. Divided by the cosecant of 210, so that's going to be the y value flipped upside down. So negative 2 over 1. Then divide, you multiply by the reciprocal. So the top's going to give you positive 2, and root 3 times 2 is 2 root 3. The 2's divide out, so you're going to be left with 1 over root 3. The sine of negative 90, so that's going to be the same as the sine of, we want to get it onto the circle, so negative 90 plus 360. Which is the sine of 270. And again, that makes sense because we know from last week that negative 90 would be down at the bottom here, which is the same place at 270. And they want the sine, which is the y value. So the sine of negative 90 should be negative 1. And then let's try that on our calculator. So the sine of, I'm going to use bracket, negative 90, negative 1. Cosine of 180, so cosine is the x value at 180, also negative 1. And then the last one, tan of 330. So if I look at 330, the tan is the y divided by the x. So the 2's would cancel. I'd end up with negative 1 over root 3 for the tan. The cotan is the x divided by the y. It's also 330. So that's going to be root 3 over negative 1. Which ends up giving you positive 1. And that makes sense too, because if you multiply the tan of an angle times the cotan of the same angle, they're reciprocals of each other, so they should just multiply to give you 1. Or you could think of it as, if we use identities, it's the tan of 330, and the cotan of 330 can be thought of as 1 over the tan of 330. That's what we learned when we did trig identities. And you can see there, then you'd get tan of 330 divided by itself, and anything divided by itself is 1. So our success criteria is to be able to memorize the unit circle, angles, and coordinates of the points. If you would like to do that, I will include some smaller copies that you could print out and write it until you've got it memorized. It would be helpful for grade 12. But mainly for this year, I want you to focus on being able to use the unit circle that we've made today to find exact trig values with minimal use of a calculator. So basically just using the calculator to check your answer rather than finding it. You're using the unit circle to find it. And understanding where those values come from. So why is the unit circle the way it looks? So we fit those special triangles into those slots, okay? And then also understanding that why is the sine of the angle the y value? Well, it's because it's a y over r, but r is 1, so sine turns out to be just the y value on the unit circle. And same with cos, just turns out to be the x value because it's x over r, but r is 1. And then because cosecant is related to sine, we can just take the y value and flip it upside down to get the cosecant. And to get the secant, we can just take the x value and flip it upside down. And then for tan, we can take the y value and divide it by the x value, and for cotan, the x value and divide it by the y value. So that's understanding where those values come from. Okay, and then the other thing we have to know then is if we're given an angle that's not on the unit circle, how to either add 360 or subtract 360 to get it onto the unit circle. So we know where it would be. All right.